Okay, so my name is Ruslan Fomkin. I'm a database engineer, so I basically participate in database development of journals of databases. I'm not involved with C++ development nowadays. I'm working with Cassandra-like code, and it's written in Java. And but previously, in one of the company, I worked with C++, so I met this meetup, and thanks to Harold for maintaining for many years, and it's still interesting, very interesting talks, and I find it's even for me interesting to participate and listen. So I'm going to talk about, first I would like to say a few words about database development in Sweden. I don't know how many are aware, but Sweden is a large, it's a small country, but many interesting IT projects, and database is not exception. Then I will spend time, most of the time, talking about Cassandra, because I cannot really demonstrate to using C++ driver for Cassandra without explaining what is Cassandra itself. And it's not a small technology to talk about. Before the demo, I will also say a few words about Astra DB, which is serverless Cassandra-based database, cloud native, and of course about the drivers itself. So let's start with development of database in Sweden. And I first, for me, like the important thing to mention, it's Uppsala Database Laboratory, which was run by Tori Rich in Uppsala University. And many PhDs, including me, completed it. And many of us working in different database vendors. And probably one of the most interesting, a reason why we've got kind of good education and the skills in databases to work on internals, it's because we worked with an engine called Amos2, which was a database used in our projects. And this system is rooted in an Iris object-oriented database management system, which was developed in Hewlett-Packard, like in end of 80s, I believe. Amos2 has a number of interesting properties. It's a main memory database, and we are speaking about beginning of 90s, where it wasn't yet popular to have in-memory databases. It supports object-oriented data model, so you can model data using inheritance and your types, and like objects with properties. And of course, it's also possible to see them as a tables, but this is give interesting opportunities in the complex applications. And it's also functional. So basically, API of it is functional based. You defined everything through the function. So it's different compared with databases where you use relational concepts and SQL. Even the Amos has some SQL-like sugaring. Also, it's functional inside. So the representations of query is in data log type of language called the object log. It's object-oriented extension of data log, and basically all predicates there are functions. So it's easy. This is allows you a generalized way to work with a query compared with relational algebra, where you need to, where relational algebra, for example, didn't have some functions which now exist. So it's was cool property. And to work with it, it's also implemented list interpreter, so it's easy to make new operators, or query optimizer was written in this. So basically, it was very extensible system, unlike majority of databases. Yeah, I just wanted to mention. And this actually became a startup product recently called Stream Analyze. And this is a segue to the companies in Sweden. So Stream Analyze was started by Tori Rich, so it's still headquartered in Uppsala with a number of his students working there. It's an embedded system to be run on it can be run on edge devices, and it allows to analyze stream of data. And one of the unique properties of it is that you can send your algorithms as data. So it's, for example, when team and so it can be run in industrial machines or some devices. And for example, you understand that you want to change how you analyze the stream coming from sensors in your industrial machine, so that people can update the algorithm and send it as soon as device is has access to internet. In comparison, coming and installing new compiled version of the software. So probably the most, like talking about Uppsala, it's not possible to talk about MySQL, because MySQL was headquartered in Uppsala at the beginning, and then they were created headquarters in the US, and then they finally was bought Sun and then Oracle. But it started from MySQL. It was started in Uppsala. It's a relational database, and it's an open source, so I will not speak much about it. Also in Uppsala, there are another database management systems. It's a home for Mimer, which is still headquartered in Uppsala, and it's probably the oldest of the databases. It's from 70s, and it continues to develop. A database which runs in embedded systems. It can be compiled by specialized C compilers for specialized devices. It's relational, fully ACID compliant, and standard SQL database. So now I would like to move out from Uppsala, and the next stop is Stockholm, company StarCounter, where I spent quite some time participating in development of the product. It's object relational database, so it allows use inheritance in the data modeling, and it's for transactional processing, like operational transactions, like retail systems. Or so it's not analytical. The main orientation was not analytical as an analytical database. It's very fast and has interesting innovation inside, and as used in number of services in Sweden, for example. I don't know how many of you knows about Geckos in Olaret. It's a huge, gigantic store where a lot of people from Sweden go in and buying because the stuff is cheap there. And it's kind of challenging for the databases and applications to run there. So StarCounter is used there as a part of retail system. Another famous Swedish database is the most popular graph database, Neo4j, and it's in Malmo. Yes, it's in Malmo, and it's the language cipher is de facto became a standard because almost all the graph databases they implement as a result. And the graph database is basically means it allows to work efficiently with data which is you want to analyze, like it's network of information. And relational database usually not good in working with such data. And then talking about Sweden, I cannot mention NDB cluster, which is a storage engine for MySQL. It's not a database by itself, but it was developed in Stockholm, started by one of the students of the Torre Rich, and was bought by MySQL, and then the founder actually created another company, DB, which was open source fork. We actually have one developer from NDB cluster here in the room. Okay, so now time to talk about Cassandra. I will try to give some concepts about Cassandra. Will not cover all of them that I think important, but at least good start point. I don't know how many people knows about Cassandra. Okay. Yeah, I didn't expect that will be many. It's not so popular. You are not often in the need of using Cassandra, where it's difficult to escape with other products. So before talking about Cassandra, I want to motivate a little bit. So Cassandra is used by many companies, and here is references from Netflix and Apple. You can process huge amount of data, do many writes, many reads, and store petabytes of data, basically because you can create a database consisting of hundreds or thousands of nodes. Yeah.
Can I just ask, is that what, a million billion petabytes of data?
Yes.
Or do they mean petabytes as in million billion bytes of data? You might not know, I'm sorry for
For yeah, I didn't.
last line there.
Yes, so
There's a petabytes of data.
I
Right,
guess it's
so-
different.
Okay, yeah.
It's just 1 petabyte.
Yeah, here it should be. I didn't check how many there are there. Okay, so why they use Cassandra? It scales to really large volumes, like petabytes of the data. It maintains read and write performance. You can extend your cluster and you get more performance. And it's because it allows to have linear scalability, which is very unusual for distributed databases, or for databases in general, and it's very difficult to distribute. It also provides high availability. It's in terms that it allows you to replicate data easily and keep system working while nodes goes down, which is not uncommon when you have so many nodes. Yeah, it has self-healing and automation, which actually helps to keep the availability, so it can restore the nodes. And it's also designed for geographical distribution, so you can distribute data into different geographical locations. So, for example, for Netflix, it's very important, and for Apple, in their usage, like with customer data. It's platform agnostic, so there are tools like Cassandra for open source tools to use Cassandra in Kubernetes, which allows you to set up locally or different clouds. And it's vendor independent. It's run by Apache Foundation, where there are no company which can push online how to develop Cassandra. So they need to come to an agreement what will be better for the customers in general. And talking about linear scalability, here's an example from which was published by Netflix that we are speaking about a couple of hundreds of nodes, and it allows to keep write performance improved linearly. There's a node that you need to have proper data model. It's NoSQL database. It has disadvantages and advantages because of this. So when we're speaking about data model, the way of how you design tables, it uses concept of tables. You start with application. So you need first to understand how application going to work with data, what data you need, and what will be the query. And then you design a table which will satisfy the query. So normally you design tables and you start to do joins and other operations. In Cassandra, it's necessary to do opposite. First, it looks like a complicated approach, but looking to relational databases, when you run to problems with performance, you start to create more indexes, and then you start to create materialized view, which will store joint data, denormalized data to be able to keep performance in the satisfy customer queries or application queries. So it's actually fast path to the need for performance, in a sense. Okay, so now I'm going deep a little bit to Cassandra itself, and I will start with how it distributes the data. So in Cassandra is a notion of rings. Ring, it's a set of nodes that store all the data of the database, and it's a ring because it's masterless. There are no node which masters. It's more like peer-to-peer, and every node, you can contact every node and get data. They will communicate with those nodes which has data and provide the result. And so they can communicate with each other. So when you have several data sets, each of them will have the same. Each of them will have a ring too. And data will be like replicated between data centers than usual setup. So when you design the data, so here you can see already that it's a data stores information about sensors that you're going to search for them using network information. And what you do in Cassandra is to define a partition key. No. Okay, mouse here. So by the values of partition key, the data will be partitioned into groups which will be stored on different nodes. So here is an example. Now it's partitioned by the network value, and each of them got assigned to different, and they were assigned to different nodes to store the data. So basically what happens when you have partition keys, the hashing function, the built-in hashing functions can be used, which will generate values to decide in which node to store. It's called token in Cassandra terminology. And each node stores a range of token values. And yeah, it looks like a circle or ring that you values, you know where will be the next values. When you go and do replication, you specify, I want to have replication factor 3, so I want to replicate data 3 times. It will store, like, in next nodes, the data will be copied there. And it's done automatically. You just need to specify that there should be replication of the data. Yeah, if there will be questions, interrupt. So terminology about the table. So the tables are stored in key spaces, and the key spaces, they contain, yeah?
Sorry, again about the replication factor, is that specified for the whole DB?
For entire data point, so yeah, so it's specified for key space.
For key space?
Yes, so all the tables that stored in one, so there you can have many key spaces. Each key space contains several data tables, and the replication factor is defined per key space per data center. Depends on the which.
For geographical place for
yes.
per key space. And basically, replication factor is how many nodes?
How many copies? On how many nodes you want to store copies?
How many? It's weird. How many nodes? So the fault tolerance.
Yes.
The fault tolerance of them. Okay.
Yes.
Thank you.
So it's automatic fault tolerance, basically.
Okay.
Yes, correct. Thank you. So then the tables contains rows and columns. Rows are partitioned into partitions, and intersection of row and column, it's a cell, so the value. And the value can be simple, like integer. It can be string, or it can be collection of data, like array. So this is terminology that is used in Cassandra. And here is example of creating key space, which probably answers your question. So here it defines to use network topology strategy. This strategy allows to make replication factor different for every data center. And here's example of 2 data centers with different replication factors, 3 and 5. When table is created, so it looks similar to relational databases. You specify fields and types, but then it's mandatory to specify primary key. And in this primary key, first portion is the partition key. It can be several columns. It can be one or several, which will be used to partition the data. And then additional columns called clustering columns, which guarantees uniqueness of the data. So primary key, it means that the data is going to be unique for the values of this primary key. And also, clustering column means it will be ordered by this value within partition. One important thing to mention is tombstones. So when you delete data, they are not removed. They are written a tombstone, meaning that this data was removed. I will explain a little bit later why it's important, but actually number of relational databases use the same concept like PostgreSQL. They don't delete data. They also say like it's now, they make a note it's deleted, but it's still present in the, you can find it in the memory or on the disk. The data can be deleted also when you specify time to leave. So you can say that I want that my data will be erased after a while, like very useful for time series data when you don't need to keep all the data. And when you change set values to null, or you work with collections, because modifying collections, it's collection stored in itself, so it says, okay, old collection is wiped, new collection is written. And a little bit about mem tables and SS tables. This is what people speak all the time when they talk about Cassandra. And I will explain from the write path. So when you write data, it's written into the commit log, so it's durable on the disk, and it's written in RAM. And this data structure is mem table where data is kept in the main memory, and it will basically store the data in the sort, like it will be partitions and the clustering key sorted accordingly, while in commit log it's appended as usual in the databases. At some moment, the memory will be, the mem table will be filled because memory is main memory is limited, and it will flush the data. And flushing the data means it will write new file which will contain SS table, immutable data. From commit log, those data can be removed, and from main memory also. SS table can be cached in memory later, but it's immutable. So new data will be written to the new mem table, and you can imagine that this data might actually overwrite writes to SS table. So it's because you cannot change it in SS table. So when it reads, it needs to check first main memory, mem tables, and then go to SS tables. And after a while, the amount of SS tables can be large. So there are special process called compaction, which is automatically usually run, but you can configure, which will go through SS table and compact, like meaning that you will store only one value of the compaction instead of several for the same row, because it was updated number of times. But I will don't go much in details. So next I want to talk about consistency, because when we spoke about NoSQL, consistency is important to understand, and it usually starts with CAP theorem that you can have only two properties out of three, consistency, availability, and partition tolerance. So when we speak about distributed database, they already made decisions that it should be partition tolerant. So you can, partition tolerant means that if you lose part of your network, your database is still going to work. So if they cannot stop, not able to communicate, nodes communicate with each other, which happens, it continues to work. And then you have choice, do you want availability or consistency? Because if you say, on one side you can say, we want to continue serve writes and read requests, which means that the other partition of those nodes which cannot communicate, they will not know about the writes which happened, and data becomes inconsistent, but it's system available, or you move to consistency, and then you need to wait until number of nodes is back, required number of nodes is back. So let's look to the Cassandra, and in Cassandra, it's actually you can choose, do you want to be consistent or available? Here is an example of if we use replication factor 3 and do quorum consistency, we need majority. If we do full consistency, we need all nodes respond that they to the query, like all read or write, depends what you do. So this is levels of consistency in Cassandra. It's starting from that you need to write only one node, or read from only one node, and it's enough. Going to, you need to write everywhere. And you can also decide between different data centers how you want to be consistent. So consistent level 1. If you write, you have replication factor 3. You wrote, you got data. The coordinator sends to 3 nodes. It got reply from one node. It was written. It replies to the client. Oh, it's done. I can, because it was required. Then it's may later make sure that it's also written to other two if the nodes are available. In the case of quorum, majority of the nodes need to reply that data was written. And in the case of consistency level all needs to reply that it was written. But you can imagine that now you need actually wait until all the nodes, even slowest node, answer it before you reply to clients that yes, I wrote and its data is safe according to your requirement. So this basically moves from reliability to consistency. While when it was only one node, I mean, it might be much faster. So when we speak about eventual and immediate eventual consistency, so in Cassandra you can do immediate consistency, and there's several ways, like write all and read from one. It guarantees that you will write consistent data. You can also say like I write one, but then read requires that all data are consistent. So if something failed, you need to wait for data to become consistent, and the automation process which allows this. And this can be for different applications, different requirements. Write intensive application, probably you don't want to consistency all on write. But opposite, if not write is not so often, you want to have full consistency on write and then read to do fast. And the recommended often way is write and read quorum. But it's up to application what will be the most useful approach. So basically, one of the important property of Cassandra, you can decide what level of consistency you want to have without going to another database engine. Okay, so now any questions regarding Cassandra? I was probably talking fast.
When you say replication factor, like number of instances of the node, is it Cassandra has its own replication factor, or you are telling the replication factor of the Kubernetes?
So it's replication factor for Cassandra nodes.
Okay.
And usually in Kubernetes, every pod will have one Cassandra node. But it's, I mean, I haven't digged into Cassandra how they implemented, for example. So, but yeah, it's Cassandra nodes. Because you don't need to use Kubernetes. You can use just Cassandra by itself. Okay, so now I want to say a few words about Astra DB. It's a DataStax product of database as a service. And basically, so it's a service on clouds to provide you Cassandra database. It's built on top of Cassandra, but it needed to do modifications to Cassandra because to be able to make it serverless. So one of the properties, it's serverless, and you can, it splits storage from
API endpoints.
Huh?
API endpoints, please. Split storage from endpoint?
No, it splits storage from actual computation, like query execution resource, like write things.
Execution engine, yeah.
Yeah, so which allows like to decide. So it's two important points with serverless. One, you can decide how much you need storage and how much you want computational resource, because in clouds it's very important. And second, you so sorry. Let's remember. And second, you can, since you split the storage, if your node goes down, which is common case, you can start new node and get data from the storage. While if it's stored inside the same node which goes down, you don't have access to storage anymore. And as a cloud, you don't need to manage yourself. So this is usually what is database as a service good for, that it's team who runs this service, they take care how to operate all the details, because operating distributed system is not easy, and it's easy to do mistakes. And the Astra DB, it's across different clouds, so it can be used in AWS, GCP, or Azure. It also can communicate with on-premise Cassandras. So now I coming closer to the demo and wants to say a few words about drivers. So for Cassandra, there are drivers for many languages. Here is, I'm not sure it's complete list, if it's up to date. And there one important project which makes life of using different languages easier, because if you use more than one language, you don't want to maintain your drivers how to work with Cassandra yourself, but you can use project called Stargate. It's open source, and it's basically provides different APIs on top of different of Cassandra versions. And some some drivers use different APIs underneath when they connect to Stargate, and then the data goes to different Cassandra versions. Here, it's basically it was probably supporting from Cassandra 3. It's open source version Apache. This it's DataStax Enterprise, or quite old fork of Cassandra, which was extended with additional capabilities like search and streaming. And Astra DB that I mentioned, it's also accessible, and it's usually the way how you access Astra DB. It's through Stargate. So your endpoint provided to the application goes through Stargate. So in my demo, when I will communicate with Astra DB, it will, so C++ driver implemented on Cassandra Query Language Protocol. And when it goes through to Astra DB, it will contact Stargate, which will then go to Astra DB. But for the case when I will use my local instance of Cassandra, I go directly. I don't set up and run Stargate. It will complicate my demo. This is why one of the reasons for me to use Astra DB when I want to have use many nodes. It's easier. OK, so now I go to demo about Cassandra. So first of all, to install Cassandra, so I use Mac. And for Cassandra, there are packages available for Windows and different Linux distribution to download. But for the Mac, it's also, they have, it's available on Homebrew. So I already installed on my machine. I'm not sure it's mentioned on the Cassandra webpage that you can go to Homebrew. And for the C++ driver, it's also available. CPP driver in the brew. So you can install from there. But I didn't know it wasn't mentioned. So I basically download source code, and then it has simple instructions how to build CPP driver for Cassandra from source code. So in my case, I did this. Now I will start Cassandra on this node before I go to the demo. So I will first Cassandra demo. So I will first demonstrate that I run my demo, and then I will go to source code. So it's very dumb toy application because I cannot really go through the large volumes of code. It reads, it checks if key space exists and creates if necessary. It's reads some metadata, and then it's create table if necessary, inserts data and reads data. I now will do to Astra. To do the Astra, I need to provide Astra bundle, which is provided when you create a database in Astra. It describes how to connect to the Astra database, and also client ID and secret information, which is provided that you need to store locally for the access. So it takes a little bit, yeah, it's not so fast because it's not localhost. It goes now to, I think, Europe. I will show the page later. So now let's go to the code. OK. It's switched. So it's very simple problem. I used only one CPP file and made CMake. So if there will be questions, interrupt me. So basically, it's a C API. So the code is written in C style, not C++ style. So I was close to the raw API provided by the driver, but it's not recommended way. You need to write C++ proper structure. So maybe someone wants to write and make here a presentation. It will be, I think, interesting project. And I will show why you don't want to do this. So first thing, I connect to the cluster, and basically, if the arguments provided, then provide the bundle and connect to the provide credentials. So it's generic information. It's already supported in the driver that you can use different approaches to communicate with Cassandra. So this one was just simple contact point to my local installation of and run of Cassandra. And some functions, they return error code of Cassandra that you can check if the operation was successful or not. Okay, let's go to the read version. So it's a read query. The API again C, so I don't use std strings. Important point that all the API, it returns futures. So you can do work asynchronously. In my application, I don't use it because I do one thing and then I want to, I do the read and I want to immediately show the result of the read. I do write and I immediately want to check that it's done. But you can do it asynchronously, which is important in the application. And then it's classical API. You when you execute the statement, you get result. The result from the result, you need to get a row. This function just returns first row because for the release version, I'm expecting only one row returned. And then go and request the values for each column and convert it into your C data types. And then it's necessary to free all the many of the returned structs need to be called free to free the resources. So it's in documentation that says that it's necessary to free. But you don't want to do this in this way. You want to have a wrapper in C++ which will do destruction, and in destruction it will call free. So for example, if you go to the CPP driver, test functions, they're actually done using more C++ styles than the API provided. So here is an example like drop table. They provide a separate function that you take string and then it will generate the query inside and will use session and object to execute, which will checks for errors. And if the errors depends what you requested, it will assert false for the test or do. But it's for the test. It will doesn't do what you normally need in application. So it cannot be used directly, but you can copy. So what else to show? So here the create table, and then I wrote some help functions which will basically take query, will make a statement, and then will execute session. It will return future. It will return future. When you call to check for error code, it will wait that future returns. It might timeout. Timeout already built in. You probably can change the timeout, but it will timeout if it takes too much time. And then you can check error. And I throw exception. For my two application, it works. But for your application, you need to know what error, how propagate errors in a way that it doesn't destroy the application. So here is example of the simple. So here key space. Okay, let's go to the main where I understand what is happening. So simple insert, just insert, simple insert statement you execute. You can do prepared statements, which gives a possibility to prepare the query and then execute several times for different values, which will be more efficient than doing the concatenate strings and doing the query. You can also use parameterized queries without prepared. And for reading here, it provides iterator, so you can iterate, or you can write nice C++ structure, which will do more high-level iteration over the data. So I don't know if there are any questions. So it's okay. Let's then go to Astra. Okay. I use free account on Astra, so I didn't pay any money. I didn't put any card for to do the demo. So I created a database. Let's actually and then increase the font. So I use sensor data key space in my application, which I demonstrated. And I want to show a few small things using SQL console to explain a few limitations of Cassandra. And if we compare Astra DB with other Cassandra-like database as a service project, many of them, like key spaces from Amazon, if I don't mistake, they provide Cassandra wires, so they talk Cassandra, but underneath there are no Cassandra. Astra DB uses Cassandra underneath. So very often when you use SQL console or SQL SQL SH, which is you can do in command line on your local instance of console, you specify you use key space, so you don't need to use key space in your following queries. So now I switch to sensor data key space, and first I will do classical example of what people do when they start to work with database. It's count everything. Sensors. Yeah, it knows. Tabulation works. So now I don't know if you can see. It says warning, aggregation query used without partition key. The reason is of this warning because when you do count everything, you need to go to all the partitions and retrieve the data and then return. And it's you will be penalized can be penalized by amount of the data that needs to be retrieved. I don't know if it actually does count on the nodes or retrieve the data and then does count. And you need to make sure that all the nodes are available. If we speak about 500 nodes, it's already a large amount. If you try to do a query, well, let's just repeat this one, and don't and specify. Try to filter on a column which is not primary key. So in our case, it was a sensor. It will fail, and you can actually overcome by using allow filtering statement. But because it doesn't have primary key, and you need to give all the doesn't have partition key, it doesn't know which partition, which node to go. So it needs to go to all partitions and retrieve data, and it can be expensive. So this is why Cassandra scales. You don't, and it also doesn't allow joins. You don't write queries which needs to go to many nodes because this is what you cannot predict, and you can easily run into the point that it takes a lot of time to execute the query. So they kind of solve and so they require to design. This is why they require to design the data based on your query, because then you can, when you use Cassandra, you can scale. You know how to keep it to scale and keep performance increasing when you need. Yeah.
What if your application user changes?
You need to create another table, and you need to move the data.
Is that easy?
Moving the data, no. I mean, it's still data. It still needs to be moved. I haven't investigated deeply how it is normally done because, of course, it's not like you first who asked the question. It's people run into this. You also provided the ability to create indexes. So there are ways to overcome this limitation with the indexes, but it's limited to what can be done with them. But it's improving. So there works to improve indexes and what can be indexes, what will be available there. Okay, I think I covered everything. So there's number of links I can put in the comments to the meetup. Basically, to learn about Cassandra, DataStax produce a lot of materials like workshops, which was recorded, and the ones that is possible to participate in future, and YouTube videos where they explain Cassandra very well without like going into marketing stuff. So when it's pure Cassandra, it's really good content. The Apache Cassandra has own website and documentation. Also, I use C++ driver documentation also to do my demo, as I'm not using Cassandra myself. I'm developer. So developers database usually know much less than users of the database about own database. And on the 20th of October, there will be Astra Day here in Stockholm. So if you really interested to investigate to use in your company, in your applications, you can sign up to this day and join. But it will be more oriented on Astra DB than on Cassandra. But they will talk also about Cassandra. You can see what is going to be there. So I think that's all. And I will, wanted to spend 45 minutes, but was talking too fast. So I spent not more time. Any questions?
Is Cassandra written in
Java.
Java?
So basically this is why I'm not working with C++ nowadays.
Astra DB also?
Hmm?
What is the infrastructure of Astra DB, also Java?
Yes.
You were using the C API, but you mentioned C++ driver there. Or
So as you've seen, the test of this driver, so it's called C++ driver, but even that provides C API, so I'm myself confused about it. But probably because it's written in C++. So you cannot use C compiler to compile C++ driver. You need to use C++ compiler, probably because of this.
So thank you. Awesome.